work, energy, and power. We have done what is work, we have done what is power, we have done what is energy. Now, today we go into the mechanical energy and its different forms, that is, different forms of energy, right? People joining in quickly. Let people join in quickly, and then we continue. Okay, we continue. In the meantime, people can come and join. So now, what's mechanical energy? Okay, the energy which is possessed by a body due to its state of rest or of motion is called mechanical energy. Okay, it's of two types: potential energy and kinetic energy. Now you can see a bird flying over here. Okay, what kind of energy does the bird have? Now I said there are two kinds of mechanical energies. One is potential energy and the other is kinetic energy. So the bird is at a height from the ground, right? So that is its position. Because of its position, it has potential energy, and the bird is flying, also. Okay, it's in motion. So the energy which it has because of its motion is kinetic energy, right? I hope the ones who are watching have understood the two forms of mechanical energy together. The kinetic energy and the potential energy together make the mechanical energy. So the two components of mechanical energy are the potential energy, which is by virtue of position, and kinetic energy, which is by virtue of motion. I move forward. Let's do potential energy in detail. Good evening, Anushka. You took a long time to join in. And Kartika Maheshwari means, which Maheshwari is that? Vanshika. No, Vaishnavi. So tell me, Kartika Maheshwari is who? Anushka, you did well in your chemistry test also. I saw you got full marks, right? So good going, keep it up. And I hope you have caught up with whatever I said. I discussed what is mechanical energy. Okay, it is the energy possessed by a body by virtue of its position or its motion. Okay, which means it has two forms. The one, the energy possessed by virtue of its position, is its potential energy. Okay, somebody else, Anushka, thank you. Kratika. Okay, Kratika. So you have joined with the correct name. I forget. Okay. And the second, the energy possessed by our body by virtue of its motion. That is known as its kinetic energy. So the potential energy and the kinetic energy together make the mechanical energy. Right? So now we discuss potential energy in detail. We discuss potential energy. Okay. Now, what is potential energy? The energy possessed by a body at rest. Okay, in its changed position. Okay, or change in size and shape is called the potential energy. What does that mean? It means, I had done it before also. I take this, I assume this to be the zero level. Okay, and this object is at the zero level now. Okay, so now what I do is I change its position of rest. Initially the position of rest is this. I change its position of rest. Okay, so now it has potential energy by virtue of its position. Got it? The other is by change in its. We take the example of a hammer. Okay, this is zero level. The hammer was over here. Got it? I raise the hammer. Okay, so its position has changed. So its position at rest has changed and it has acquired some energy. Okay, it has acquired some energy because of which it can do work. So it has got potential. That's the potential energy. As soon as I release it, it goes down. Okay, I can do work with it. Okay, The second case, which I said, is its change in its size and shape. Okay, change in its size and shape. So let me pick up this. Okay, this is a spring, you can see. Okay, I pick up a can, a Sprite can, an empty Sprite can. I place it on top of this. Okay, and I press it. I have changed the shape. Okay, I've changed the shape. I release it. Here it flies away. Okay, so when I pressed it, I changed its configuration. Okay, I changed its shape, and the work which I did, that got stored in the form of potential energy. As soon as I released it, that potential energy threw that can away. Okay, one more example. Many of us do this in school. Okay, now I have this rubber band with me. It's between my fingers. I have a bit of paper. I love that, I love doing it. I was thrown out of my class many a times for doing this. Okay, here I pull it and it flies away. Okay, so what I did, I changed the shape of the rubber band. And when I did work on it, it got stored in the form of potential energy. Another thing, my son cried, I tore away his kite to make this. Okay, a bow and arrow, Jai Shri Ram, and there it whips. Misfire, misfire. Okay, arrows also misfire, don't worry. And now, this time I Jai Shri Ram and fire, there it goes, cut. Okay, so what I did, I changed the shape of the string. I changed the shape of the string, and because of this is known as elastic potential. Okay, this is known as elastic potential. This is known as elastic potential. Okay, I press a balloon, it regains its shape. That is elastic potential. And this is gravitational potential. I do work against the gravity. What? Okay, you have been silent for so long. You must be thinking that sir is not asking anything today, right? So the first question, here it comes to you. If I need to lift this hammer, okay, without accelerating its motion, its mass is m, what is the minimum force which I will be needing? Its mass is m. I want to lift it without accelerating it, okay, which means uniformly. What is the minimum force which I'll be needing it? Start punching. Waiting for your answers, huh? So I've given you examples of a spring. I've given you example of a bent bow. Then I have given you example of a stretched rubber band. All these are elastic potentials. Then I gave you example of raising this marker. That was gravitational potential. I gave example of raising a hammer. That was gravitational potential. Waiting for your answers. Today my network is good, isn't it? Say yes. The picture quality is good. The sound is good. No buffering, no lagging. Give me yes, then I give you the good news. Waiting. What happened? Have you gone to sleep, girls? I know it's late. Are you going to sleep? Come on. Waiting for your answers so that I can move forward. Okay, so it has two forms. The first one is gravitational potential energy. What happened, girls? You're not writing anything. The second one is elastic potential energy. Hey, girls, what happened? Not writing. I said, what is the minimum force I will be needing to lift this hammer if its mass is m? And nobody has punched in. Punch anything. What difference does it make if it is wrong? At least you tried. And if you don't try, there's a guarantee that you will fail. If you try, chances are you may succeed. So giving me the answer. Still waiting for your answer. No? What happened? They are not answering anything. Anushka, are you still there? Send me a yes at least. Send me a yes at least. We don't have a feed, just have a look at the feed. Look at the feed and tell me what happened. The girls are not answering anything. Just have a look at the feed. Should I continue? Okay. I don't get a feed. You share the feed with me. Till then I continue. Okay. Now, what happens? Every body experiences a force of attraction. Okay. This force of attraction is due to the Earth's pull, due to the Earth's gravity. Okay, and it is known as the force of gravity. Okay, how much is this force of gravity equal to? That is what I had asked. Okay, that force of gravity is equal to the weight of the body, which means the mass multiplied by the acceleration due to gravity, mg. Okay, mg, that is the weight of the body, is the force. Now if this force is pulling it down and I bring a force which is equivalent to it, okay, then it should be slightly greater than to be precise, okay, then I can raise this. Okay, but we take it as same as the weight and we take it as mg. So this weight is pulling the body down, and if I need to raise this above the earth's level, I'll need a force. All good? Why are the girls not replying? All good? Tell me. These are smart girls. They reply quickly. I haven't received their. Huh? Okay. Okay. What happened? Why are you pulling it out?
Thank you, sir. Thank you, sir. It is coming.
That though had come earlier itself. Now what? Okay. Chalo, I continue. And since the number of students is less, I'll finish it quickly so that in the next class we can continue from here. I'm not getting any response also. It seems everybody is going to sleep.
Then, sir, please explain it again.
Okay. Kratika. Where were you, Kratika, till now? I said, see, that potential energy is of two kinds. Okay. The first one is gravitational potential energy. Okay. Now, every body is pulled by the earth towards itself. Okay. And how much is that force equal to? Okay. If the body has mass m, then there is acceleration due to gravity g acting on the body. Okay, so the force becomes mg, mass into gravity. That force is pulling the body towards the earth. Okay, the gravitational force. Now suppose I want to raise it. Okay, so I have to apply a force which is greater than this force. Only then algebraically I can raise it up, isn't it? I cancel that and I apply a force which can raise it up. So the minimum force which I need should be almost the same as the weight of the body. Okay, that is the gravitational force acting on the body, which is equal to mg. Got it? So if I do some work on the body, in the previous class we had learned that if I do some work, it gets stored in the body in the form of energy. So if I do some work on it, then I apply a force which is equal to the weight of the body, which is equal to the force of the gravity, and I raise it. Okay, now suppose I have raised it to a height h. Okay, to a height h, and what is the force which I applied? I applied a force equal to the weight, that is mg. Okay, so what was the work done? The work done is equal to force into displacement, right? What is the force here? The force is equal to mg. What is the displacement here? The displacement is h. Okay, so mgh, I represent potential energy by u. So mgh is the potential energy which a body will gain when it is raised to a height h, where mg is the weight of the body. Clear? Everybody understood? Give me a yes. Give me a yes so that I can continue. Okay, so you must have understood that potential energy possessed by a body due to the force of attraction of earth on it is called its gravitational potential energy.
Yes, sir.
Very nice. What is gravitational potential energy? The potential energy possessed by a body due to the force of attraction of earth on it is called its gravitational potential energy. Okay. Now I give you a question. Anushka, you're not there or what? Kratika is answering only. Okay. Now I give you a situation. So I had raised it to a height h now. Okay. I do make it h1. Suppose I raise it to a height h2. Okay. This was A. This is B. At which position, A or B, will the body have greater potential energy? At which height, A or B, will the body have greater potential energy? उसकी potential energy ज़्यादा कहाँ होगी? Height H1 पे या height H2 पे? Okay? H2 जो है वो H1 से ज़्यादा है. Quickly, कहाँ पे potential energy ज़्यादा होगी? Waiting.
H2.
H2 पे ज़्यादा होगी. किसने जवाब दिया? Kritika. Okay, only Kritika is answering. I don't know. Anushka has gone to sleep, I suppose. Okay. Chalo. So, what is the difference in potential energy? I write delta U. Okay. Delta U. अब H1 पे potential energy क्या थी? H1 पे potential energy थी mgh1. Okay. और यहाँ पे क्या है? mgh2. तो this is greater, so I'll write mgh2 first minus mgh1. Okay, so what is the change in potential energy? The change in potential energy is mg h2 minus h1. Right? Very simple. Understood this? Okay. Now, Kratika, one more question for you. अब मैं कहता हूँ कि मैं इस बॉडी को एक इनफाइनाइट डिस्टेंस पे ले गया अर्थ से. Now, what is the potential? What is the potential it has? जल्दी से जवाब दे, फिर हम आगे बढ़े. H2 is correct. ठीक है. I have explained it also to you कि डेल्टा P यानी कि पोटेंशियल इनिशियल और फाइनल में डिफरेंस कितना होगा, डिफरेंस पोटेंशियल का, पोटेंशियल एनर्जी का, एंड दैट बिकम्स mg h2 minus h1. अब मैं कह रहा हूँ कि मैं बॉडी को एक इनफाइनाइट डिस्टेंस पे ले गया, तो अब इसकी पोटेंशियल एनर्जी को क्या होगा? बढ़ जाएगी, कम हो जाएगी, क्या होगा? Shoot quickly. We'll finish it quickly today. Okay, we'll not spend much of time because the number of students is less. It's quite late also. Okay, some parents were telling also that it's very late. I give you the good news that my broadband is in place. That's why today we don't have any lagging problems. Okay, that's why the signals. Sorry, it'll increase. Okay, Kratika says it'll increase. Now Kratika, okay, work done is equal to force into displacement. ठीक है, आपने पिछली क्लास में क्लास 9 में पढ़ा है ग्रेविटी के बारे में. ठीक है, डिस्टेंस बढ़ेगा तो ग्रेविटेशनल फोर्स कम होगा कि बढ़ेगा. इनफाइनाइट डिस्टेंस है तो वो ज़ीरो हो जाएगा, फोर्स ज़ीरो हो जाएगा. अगर फोर्स ज़ीरो है तो वर्क डन ज़ीरो हो जाएगा. So the potential becomes zero. So if a body is at a very far away distance where the force of gravitational pull of the earth is not working, there's no force. Okay, so no work. No potential over there, zero potential over there, right? And otherwise, if it is a finite distance, then as the distance increases, so does the potential increases. Okay, but if the distance is so big that the force of the gravity will not act. Very nice, Anushka. Where were you? Okay, if the force of gravity is very far away, then you are listening to whatever I said, I suppose, Anushka. Okay, now we go back to elastic potential. Anushka, have you understood everything what I said? The thumbs up means you understood everything. Okay, otherwise I explain it once again to you. Kratika, understood, beta? When the distance is finite, as the distance increases, the potential energy increases. Right? Now we go to elastic
Yes, sir.
potential. Very nice. Very nice. Now we go to elastic potential.
Kritika also says yes, sir.
Okay, very nice. Now we go to elastic potential. Okay, when an external force is applied on a non-rigid body. What do you mean by non-rigid? Okay, non-rigid. Now see, this I apply a force. Did anything happen? Nothing happened because it is rigid. Okay, so my applying a force is not changing its shape. It's a rigid body. On the other hand, I take this, I apply a force. Does the shape change? Yes, it changes. So non-rigid body. Hey, give me the can again. I love making it fly. Okay, so I put in my can launcher. Here I stay safe, huh? It may land on your head. Here I apply a force. There it flies. Okay, so when I apply a force, then it is a non-rigid body. Okay, it changes its shape. It gets deformed. Deformed matlab object which can change its shape. Very nice. So it gets deformed. Uska shape जो फॉर्म था उस फॉर्म से दूसरा फॉर्म बन गया. It gets deformed. So elasticity क्या करती है? उसको वो फॉर्म वापस लाने के लिए बोलती है. जब हमने ये यूज करा था यहाँ पे भी यही था. Hey, give me my arrow. Hey, quickly give me my arrow. Okay, यहाँ पे भी यही है. You can see the thread over here. Okay, when I pull the thread. Okay, when I pull the thread, no, my arrow is lost. It had flown that side. Okay, when I pull the thread. Okay, when I pull the thread, then its shape changes. This also is non-rigid. Okay, now since it is here, there come my arrow. I lost it. People had captured it. Enemies. Okay, so now when I place the arrow over here like this, okay, you can see the shape is changed. Can you see that? Okay, the shape is changed. And what will the elastic potential do? The elastic potential will try to bring back the shape. Okay, and that elastic potential, because of the change in shape, is stored over here, and the energy will be transferred to the arrow. Okay, and the arrow flies away. There it goes. Okay, so I hope you have understood elastic potential. I'll read it out what's given in your book once. Okay, it says when an external force is applied on a non-rigid body, a body whose shape can change, it gets deformed due to change in its size and shape. On removal of the force, till the time I'm holding the string of the bow, the arrow doesn't go. Okay, till the time I'm holding the string of the bow, the arrow doesn't go. As soon as I release the string, now the arrow flies away. Okay, so on removal of the force, जैसे ही हमने force बंद किया, on removal of the force, it regains its original form. वो elasticity आ गई play में और उसने अपना shape वापस regain करा. Okay, it regains its original form due to the property of elasticity. Okay, because of the property of elasticity, it regains its shape, original shape. Okay, and whatever, and the work which was done in deforming the body is now stored in the form of elastic potential. It gets transferred to the arrow. The work which I had done in pulling the string, okay, it got stored in the string in the form of elastic potential. As soon as I removed the force, okay, this elastic potential transferred the energy to the arrow and the arrow flew away. Right? Everybody understood? Give me a yes, Anushka. Object which can change its shape was non-rigid. Now you have understood, Anushka, Kritika. Tell me. Nice. Anushka gives me a thumbs up. Okay. And what about Kritika? Kritika, have you gone to sleep now? First, Anushka had gone to sleep. Now, Kritika, it seems, has gone to sleep. Okay. And we have already discussed the gravitational potential energy at a height in this when I use a force which is equivalent to the weight. Kritika says yes, sir. Okay, then what happens, it get raised to a height h, the force is equal to the weight, which is mg, the displacement is h, so the gravitational potential in that case is mgh. That is what your book gives. Okay, then your book talks about difference, delta p, delta u, that also we have talked. Okay, the difference in potential. Okay, if h2 is greater than h1, then delta u is equal to mg h2 minus h1. That is the change in potential. जितनी हाइट ऊपर गई उतना ही, उतना multiplied by the weight is the change in potential, right? Next, what do they talk? They talk that अगर बॉडी गिर रही है, if this was raised, when the body was raised, okay, now if the body is falling, if the body is falling, so क्या है, उसका जो h1 था यहाँ पे था, अब मैंने उसको गिरने दिया और वो इस हाइट पे आ गई, which is h2. Okay, so in this case, which is greater, h2 or h1? Yeah, U is equal to mgh, says Anushka perfectly. Okay, that is potential energy, and delta U is the change in potential. जब मैं बॉडी को एक हाइट, बॉडी इस हाइट पे थी, h1 पे थी, और मैं उसको रेज करके इस हाइट पे ले गया, which is h2. So what is the change in potential energy? That is mg h2 minus h1. Anushka says h1 is greater. बढ़िया. Okay, initial position ये थी और अब बॉडी यहां से गिर रही है, so which means h1 is greater than h2. So in this case, what is the change in potential energy? Change in potential energy, उसकी फाइनल क्या हुई? फाइनल पोटेंशियल एनर्जी क्या हुई? mgh2. इनिशियल क्या थी? mgh1. ज्यादा कौन सी है? mgh1 है. So it becomes mgh1 minus mgh2. So in this case, the change in potential is equal to mgh1 minus h2. Clear? Very nice. Anushka gives me the answer. mgh1 minus h2. Thumbs up. Okay. We have done potential energy today. Now kinetic energy will take quite some time, and the number of students present today also is quite less. Okay, so I do one numerical related to this, and then we finish the class here. Okay, I'm so sorry I had to change my timings today, but it was for a good cause. The people had come, they have installed my broadband, and now it gives 50 times the speed what my mobile used to give. So you must have seen there's no lagging today. The picture quality is good, the sound quality is good, right? So let's take a numerical now related to this. When I write the question, you can start solving it. Okay, I'll have to wear my reading glasses to check the question. What does the question says? Okay, the question says 500 liters of water. Okay, जिसकी डेंसिटी है 1 kg per liter. Okay, इसकी डेंसिटी है 1 kg per liter. Okay, is raised from 4 meter. Is raised from 4 meters to how much? 12 meters. To 12 meters. Okay, taking g is equal to 10 meter per second square. क्या निकालना है? State whether the potential energy of water will decrease or increase. Okay, u increase होगा कि decrease होगा, ये बताना है पहले. Okay, and second, find delta u. Find delta u. Okay, Anushka says it's okay sir. I mean, तुम impress नहीं हुई, don't tell me. But ठीक, it's okay sir means ठीक. इतना स्टैंडर्ड बढ़ गया तो कह रही ठीक. Okay, so 500 liters को हम, उसका मास कितना हो गया? it becomes m is equal to 500 liters into the density, okay, which means 1 kg per liter. So liter cancels. So m is equal to 500 kgs. Okay. और उसके बाद क्या निकालना है हमने हमने उसका वेट निकालना है, राइट? पहले उसकी हमने हाइट निकालेंगे. सो 500 kg हमने निकाल लिया उसका मास. एंड नाउ वी गो टू 1500. Okay, 500 kg. Mass is 500 kg and G is 10. Okay, so potential energy delta U is equal to mg h2. H क्या दिया हुआ है? h1 is equal to 4 meters and h2 is equal to 12 meters. So mg h2 minus h1, which means it becomes 500 into 10 into 12 minus 4 is equal to 5000 into 8 is equal to 5 8 is 40. Okay, what will be the unit? What will be the unit? Mass is 500 kg. Yes, correct. Okay, mgh2 minus h1 says Anushka, correct. It will be joules. Okay, so it becomes 4 into 10 to the power 4 joules. That is the change in potential energy. And the first part we didn't answer. Oops, we didn't answer the first part. The first part is, since H is increasing, hence U will also increase as U is equal to mgh. That was the first part. We had missed the first part. 4 into 10 to the power 4 joules. That's correct. So that's all for the day, okay? Please practice questions related to this, and in the next class when I come, I'll take you to kinetic energy, okay, and we'll do derivations related to kinetic energy. We'll do the relation between kinetic energy and momentum, and then we'll go to numericals. Right? Thank you very much. Good night. Thank you very much.